Hi, uh, let me teach you about a trigonometric function cos of a plus b. Okay, let me share the whiteboard and then we can take it from there. Okay, so this is the whiteboard. Okay, uh, before going into that, the formula which I'm going to prove today is cos of x plus y is equal to cos x cos y minus sin x sin y. Okay. Before proving this, let me tell you about, first we have to see what is cos of minus x and what is sine of minus x. That will be used in derivation of this. Uh, I'll tell you about that. Let me say first, if this is a circle, okay, and if the center of the circle, let this be O, okay, let this be O, and let there be point. Let's take it here. Let this be point P as the coordinate of P is AB. Okay, and let this be a unit circle. So unit circle means the radius of the circle is 1 unit. Okay, and let this be the axis, x-axis. Okay, so now if we have a point, say, and let this angle be x. So x is this, and if we want to have minus x, so that would be angle this from the positive axis towards the clockwise direction. So this is minus x and this is x. Okay, but the value of the angle is same. It's just the direction. Okay, so now, and let this be Q. Okay, so the Q point, which is having the same angle. So these two triangles, say let this be R. These two triangles, ORP, triangle ORP and triangle ORQ will be congruent. And why it will be congruent? You can just see that OP is equal to OQ because that's 1 and that is radius. Okay, and the value of the angle POR is same as angle QOR. Okay, and the side, common side, that is OR is equal to OR in both the triangles. So the triangles are congruent, right? This is by which theorem? That is side angle side, SAS. So triangle ORP is congruent to triangle ORQ. And why I'm saying that, why I'm trying to prove that this is congruent, from the congruent, from then the corresponding part of the congruent triangles will be equal. That means RP is equal to RQ. Okay, so this length, what is this length? RP is actually B. So this will also be, RQ will also be B, but this is below the x-axis. So this will be, the coordinate will be minus B. Okay, and OR is what? The x coordinate for this point P. So that will be A. So the point Q is A minus B. Now what in this triangle, triangle ORP, in triangle ORP, cos of x is equal to adjacent side by hypotenuse, that is OR by OP. So that will become cos x is equal to what? OR is nothing but A. Okay. And in triangle ORQ, cos of minus x is equal to what? That will be OR by RQ. that will be cos of minus x will be equal to adjacent side by hypotenuse. So that is OR by OQ. OR by OQ. So that will be again A. And OQ is 1 only. So A. So from here, I'll just erase this this part, or maybe I'll go to the next page. Okay. So from that particular thing, we can say cos of x is equal to cos of minus x. Okay, because this is coming as this, and again, if I copy this circle from the same circle, we can say what is. I'll erase this part. I want to be in the same page, so that is what. Let me put it here. Okay. Let me draw it here. So, what is sine of x? Sine of x is equal to opposite side by hypotenuse, that is PR by A. So that will be B, and sine of minus x will be opposite side. Opposite side is RQ. RQ by hypotenuse, that is minus B. Okay. So from here, we can say sine of minus x is equal to minus B, which is nothing but minus of B is sin x. So minus of sin x. Okay. So from here we are able to deduce that just a sec, that from here cos x and cos of minus x are same. So we can say cos x is equal to cos of minus x. Sine of minus x is equal to minus sin x. Okay. This I'm going to use in the proof of the function of cos of a plus b. So remember, the sine of minus x is equal to minus sin x, and cos of minus x is equal to cos x. So these two things will be using it in the proof. So let me come quickly to the proof of cos of x plus y, which we have to prove as cos x cos y minus sin x sin y. Okay, so let me draw a circle. Draw a circle here. Okay. So this is a circle. Let's take the center as P1, and let this be unit circle. Okay, so and let this angle be from the positive x-axis. Let this be x. Okay, and let there be another point. You may want to put it like this. Okay. Same angle, and I'm putting as from x-axis. So this is, let this be minus 5. Okay. So this is what. Let this be P2, and let this be P3, and let this be P4. Okay. So what is this now? This unless we have got what is this point A, for a point do sin x, 2 point. So with this angle, so this will be cos x and sin x. If x is the angle from positive x-axis, right? Okay, and similarly, this will be cos of x plus y and sin of x plus y. Okay, and what would be this? If I say P4, and this will be what? Cos of minus y and sin of minus y. Right? Any point on this circle, unit circle, on the cos x sin x, where x is the angle, right, from the x-axis, positive x-axis. Okay, so that is there. Now what we have to do is, so we have found out all these three points, and what would be this P4? This is just on x-axis, so this is the radius, so this will be 1 and 0. Okay. Now what I'm going to do is, see, if I join these 2 points, P3 and P1, okay, and what I'm going to do is joining these P2 and P4. Okay, now if we consider these two triangles like O, P2, P4, this is triangle O, P2, P4. Okay, and I'll take O, P1, P3, P1, P3 in these two triangles. Okay, let's consider these two triangles. So first O, P2, P4, O, P2, P4. What is angle O, P2, P4? Angle P2, O, P4 will be what? This is x plus y, or you can say mod of x plus y. The value of x, y, yeah, so it will be x plus y. X is positive, so it will be again this angle will be x plus y, right? If this is 30, this is 40, this will be 70, right? So both angles are same, and the other two sides. So in these two triangles, this angle, the middle angle is same, and what you can say OP2 is equal to OP1 and OP4 is equal to OP3. So these are radius. Okay, these are radius, which is equal to 1 actually. Okay, so now these two triangles are congruent. Triangle OP2, P4. Triangle OP2, P4. This OP2, P4 if I draw it with that, this is one of the triangle OP2, P4. Okay, will be congruent to triangle O. I'll draw it with green OP1, OP1, P3, right? So these two triangles will be congruent. Okay, now if these two triangles are congruent, that means the corresponding part will be equal. So which means P1, P3 will be equal to P2, P4, right? P1, P3 is equal to P2, P4, P2, P4. Now, from distance formula, if you know the coordinates of the 2 points, we can find the distance between those 2 points. So what would be P1, P3? P1, P3 is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Let me take its P1, P3 square. What will be P1, P3 square? X2 minus x1 whole square. So that will be what? Cos x minus cos of minus y whole square plus sine of x minus sine of minus y whole square, right? P1, P3 whole square is it. And now let's take P2, P4 whole square. Okay, let me try to put it on this page only. Let me take this down so that it will be helpful. Yeah. So P2, P4. P2, P4 whole square. P2, P4 whole square will be what? Cos of x plus y minus 1 whole square. Let me just a sec. Yeah. So P2, P4 whole square will be cos of x plus 1, x2 minus x1 whole square, cos of x plus 1, cos of x plus 1, x plus y minus 1 whole square plus sine of x plus y minus 0 whole square, right? So these are the two things which we will take it forward. So P1, P3 square, we have found P1, P3 square, right? And P2, P4 square. This is P2, P4 square. P2, P4 square. Let me take it to the next page. So what we have found is P1, P3 square and P2, P4 square, right? So that was P1, P3 square is cos x minus cos minus y. Cos x minus cos of minus y square plus sin x minus sin of minus y plus sin x minus sin of minus y whole square, right? And P2, P4 square we got as cos of x plus y minus 1. So that was P2, P4 was cos of x plus y minus 1 whole square minus 1 whole square plus sine of x plus y minus 0 whole square. Now from the P2, P4 square, now from the previous when the two triangles are congruent, we know that P1, P3 is equal to P2, P4. So P1, P3 square will be equal to P2, P4 square, right? So P1, P3 square will be equal to P2, P4 square, which implies, right, which implies both these will be equal. So the first part is cos of x minus cos of, now let me do this. Now further we can write it as we have earlier proved that cos of minus y is equal to cos y. So P1, P3 square, the first part will be cos of x minus cos of minus y will be y. I'm keeping it as y, cos y square plus, and sine of minus y is minus sine y. So this will be sine x minus and minus plus, so sine x plus sine y whole square. Okay, so if I further simplify it, it will be what? Cos square x plus cos square y minus 2 cos x cos y, and this will be sine square x plus sine square y plus 2 sine x sine y. Okay, now what would be this? This will become cos square x plus sine square x is 1, and cos square x plus sine square x is 1, and this cos square y plus sine square y is equal to 1, right? So I'll derive it maybe later about, you might be knowing that cos square x plus sine square x is 1. So this 1 plus 1 will be 2. So it will further simplify to 2 minus 2 cos x cos y plus 2 sin x sin y, right? So this, and how about P2 P4? If we simplify further, P2 P4 whole square will be, this is a minus b whole square, that is cos square x plus y plus 1 minus 2 cos of x plus y, right? And if we simplify further, this sin x plus y minus 0, that is sin x, so it will be sin square x plus y. Again, in this we have cos square x plus y plus sin square x plus y. We can say that x plus y is z, so cos square z plus this x plus y is z, so sin square z. So cos square z plus sin square z is anyway 1, which is this. So this will be 1 plus, and this is another 1. So this will be 1 plus 1, that is 2. So this will be 2 minus 2 cos x plus y. Now equating these two, P1 P3 square is equal to P2 P4 square, what we are getting is 2 minus 2 cos x cos y plus 2 sin x sin y is equal to 2 minus 2 cos of x plus y. Okay, so that is what it is. Now we can further say, which implies 2 can be cancelled from both sides, and yeah, so it will be, if you take it here, just see it minus 2, this part I can take it to the left hand side, so it will be 2 cos of x plus y is equal to, and we can take this 2 cos x cos y minus 2 sin x sin y. Okay, and I'll write it maybe here. I'll erase something from this board. I'll not erase it so that it will be useful. I'll just put on this side only. Let me draw a partition. So what we are saying, from this 2 cos x plus y, so what is that? 2 can be cancelled from the both ends. 2 can be taken as common. So cos of x plus y is equal to cos x cos y minus sin x sin y, which we have proved. I think that's it. Thank you. There might be something where I'm not able to write it properly in this through this digital pen, but still, I think that is what I wanted to prove. So cos of x plus y is equal to cos x cos y minus sin x sin y. If you face any doubts or anything, you can write it in comment. Right. Thank you all. Thanks.